Yeah, hello, good evening, Moira Kansha. Any doubt in the last session
No, ma'am.
in the quality check?
No,
Okay,
ma'am.
okay then. So, can you tell me now what is the next step?
Trimming?
Mm-hmm. Okay. So, we saw in the forward and the reverse file, the adapter sequence was present, right? So, our next step is what? To clean the unwanted sequence. So, here we can write in the step 4, that means cleaning of unwanted sequence. So what is the unwanted sequence? Ad- Adapter or primer sequence by fastp tool. Okay, so you guys are having this fastp tool.
Yes, ma'am.
Yes, ma'am.
Okay,
Ma'am, should we open this fastp tool inside the DNA seek folder now?
yeah. So from here
Okay.
you just open the ws.
Do I have to type fastp now?
Yeah, type fastp.
Do I have to type fastp, ma'am?
Yes, Moira.
Oh,
So I will write here installation is by sudo apt get install fastp. Then how to open the manual? So you just have to simply type fastp. That's it. Now, if your manual is open, that means the fastp tool is there. Now, how to run this tool? So you need to call the fastp tool, and after this it is written option. So there are a lot of options below given here. It's up to you which option you want to use here in the fastp. You can use that. So I'm going to use this -i. So where -i is containing your forward file. Okay. Then this -o is your output of your forward file. Okay. Then next, this is your input of your reverse file. And this is your output of your reverse file. And below, there is an option that is the adapter. Can you see this? We are going to use this option. Okay, or maybe you can use this also. Yeah, this one, where you have to provide all the adapter sequence in this file. Okay, so how to do that? From here, yeah, below just type here touch and write adapter dot fasta, then enter. Then do it ls. Now see, the adapter.fasta file has been created. Go inside your this folder. Then you open this file in your notepad. This adapter.fasta.
done, ma'am. The notepad is supposed to be empty, right?
What? Yes, 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 yes. We have to load the
Okay.
data here. Okay.
Okay, ma'am.
Just wait. I don't know why it is stuck here. Okay. Now in this adapter.fasta, like this file has like we have created. So we already know the FASTA sequence is what a two-line format. It is starting with the greater than sign, then it is having one ID, and below there is a any sequence, right? Correct? This is your FASTA file. So now what we have to do, just type here H1, and below you have to open this forward file here and paste this sequence.
Ma'am, could you please share the sequence in the message because the browser is not open for me.
Okay, like this. Okay, I will share the sequence also. Now next thing is below, if you go, there is a second adapter sequence also present. um, yeah, here it is. Simply just copy this and go to this adapter.fasta file, and below now type greater than sign and h2, give your sequence. Now if you see, there is a adapter content also below, so we have to see which is the adapter here. This is the blue color. So blue color is Illumina small RNA 3' adapter. So we have already seen here in this FastQ say folder. We have to go to the configuration file and in the adapter list. Now there is, just let me check it. What is this? Illumina small RNA 3'. This is the sequence, right? So from here you have to copy and put that in your adapter.fasta like this. Are you get?
Ma'am, what does this hex stands for?
No, no, no. You have to provide any ID, na. If you remember, if you open any FASTA sequence, it is going to start with the greater than sign. You have to put any one of the ID here. Then below you
It's
have to
just
put
a
the sequence.
random
Exactly,
identification, right?
exactly. Yeah.
Okay, okay.
Then you can check it from your reverse file also. There is a sequence. You can see here. Simply copy. You can see this is the sequence present. Now this is your Illumina universal adapter. Again, go back to your adapter list and then take the sequence from here.
Ma'am, sorry to interrupt. Could you share the previous sequence in the message box?
Yes, yes, yes. Which one? This fifth one?
Yes, ma'am.
Okay.
Fourth?
Fourth?
Yes, ma'am. H4, H4 and H5, ma'am.
Yeah. Did you got this? Then save this file.
And what was the final sequence in the adapter list? It was it
This was the
release?
Illumina Universal adapter.
Okay, ma'am.
And then you can save this file by Control S. Done?
Yes, ma'am.
Yes, ma'am.
Okay. Now let's make a command how to run this. Okay. So I will write here usage. So first type here fastp. Then I'm going to use -i, right? Just wait. So in the -i, what we have to do, we have to put your this file, right? The forward file. And then -o here. So again, I'm going to give a name of like trim so that we can identify what is the output of my this file. So trim, then again, I am going to write this. Then -I here, where I have to provide here reverse file. Then -O, this is the output of your reverse file. Then I'm going to use one option, that is the adapter. I can check it from this terminal, adapter. This one, okay. Then give your file name, that is your adapter.fasta, which you have created right now. Did you got this command now?
Ma'am, could you please stay on the screen for a second so
Yes,
that we.
yes, sure, sure, sure.
I couldn't understand this last step, which is double hyphen adapter underscore pasta. What is that, ma'am? What
This
is it
one,
used for?
this one.
Yes, ma'am. Yes, ma'am.
See, if you remember, like in the adapter.fasta we have created, right, where you have load all the adapter sequence, correct?
Yes, ma'am.
So this is the input file, na? So we are going to take this option so that it is going to remove all the adapter sequence from these two files, okay? And it is going to create this two output, this one and this,
Okay, ma'am.
okay? Done.
Yes, ma'am.
Moira, done.
Yes, yes, ma'am. Now, do I have to copy this in the WSL?
Now, again, this, like, you can copy this and open the folder, then you can run this.
For me, it says adapter.fasta doesn't exist. The
Uh,
file name is just adapter for me. So what should I do now?
can you like show me your screen? Share.
Can you see my screen?
Uh, do it ls here. Okay. So what is the command you are giving? Mm, the spelling
This
is
one.
wrong, Moira. Spelling is wrong.
Oh,
Adapter
okay.
dot
Okay.
fasta.
Okay, I'm
Now
sorry on
try.
that.
Now try. Don't. Yeah. Now try this. Enter. Is it working? Yeah.
I've given enter,
Yeah.
but
Yeah. 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 It's working. You can see the cursor is blinking here, right?
yes,
So it
yes,
will
ma'am.
take
So
time.
does that mean that trimming is happening? If the cursor is like that, does that mean
Yes.
that
Yes.
trimming is
Yeah.
happening right now?
Exactly. Yeah.
Oh, okay. Thank you.
Mm-hmm. Done.
It's still blinking, ma'am.
Okay. Okay. Just let me know. Huh?
It's done, ma'am.
Okay. Moira.
Yes, for me as
So you can see here the duplication rate. So this indicate the nearly 60% of your reads were identified as duplicates. And duplicate can also arise some like
well.
yeah, yeah, yeah. Yes, Moira.
The screen is not shared, ma'am.
Oh, sorry, sorry. Just wait. Now Can you?
Yes, ma'am. Yes, ma'am.
Okay. So you can see the insert size peak here first. So this indicate majority of your paired end reads have a separation of around 170 base pair. Then duplication rate is your this much 58%. So this indicate that nearly the 60% of your reads were identified as the duplicates, and duplicates it is arising due to maybe the over amplification and there are some biasness in your data. Then you can see like the total read count is there, okay, this much. Then after filtering all the result, this many reads were passed, and then this is failed due to the quality, or you can see the low quality. Okay, so this many reads were discarded as they were having the low quality, and there were no reads which is having the n content, and this also reads were failed here due to some, like you can say these are short sequence that is present in your file. Okay, and these are reads which are trimmed, okay, which is having the adapter sequence. So now you have trimmed and you can see this is my output now. Can you see? Now, after trimming your data, we need to check now whether it has removed adapter sequence or not. Correct? So what is the next step, guys?
Ma'am, for me there's
Quality
something.
check, ma'am.
Is it that file, ma'am?
Which one?
Trim with underscore one and
Yes,
underscore
ma'am.
two.
Yes, ma'am. These are the output. Trim one.
Okay, okay.
You can see na in the command also. This is your output of your forward file, and this is the output of your reverse file, ma'am.
Yes, yes.
Okay. Now again check the quality of trim data by using fastqc. Now call the fastqc tool. Now what is my input here? Can you tell me? Can
Your
you?
trimmed
Yeah,
file.
yes. So this will be my input now. You can create this command first. And then you can run this. Is it working? This step fast QC?
Yes, ma'am.
Okay.
Ma'am, the analysis done for both files for me, ma'am.
Okay, okay.
Yes, ma'am. It's done for me too.
Now you can see it has generated your two files again, HTML and your zip file. Can you see? And again, now you can open your trim file. And then now you can see here the primer sequence is removed. Can you see? If you scroll down, all of them it is having no hit, right? And you can check the adapter content also. Now it is removed. Can you see that? And you
Yes,
can
ma'am.
also check for the other. I guess it is okay. It is still running in my system. You just check it from the reverse file also. Is it present or not? Just check it.
It's clean, ma'am, now.
Right? So this is how we trim your like adapter sequence, guys. This is not the file. Yeah. Adapter content, no. And then there is no hit. Can you see? Did you got this step? Trimming?
Yes, ma'am.
Yes, ma'am.
Okay, perfect. So now what is the next step? Any idea? Now we have removed all the adapter. Now our data is good. So what is the next step?
Alignment, ma'am.
Yes, alignment. So next step is to aligning the reads on the reference genome by using one tool, that is the BWA. So first thing is we need to install, just type sudo apt-get install BWA. Install this tool, and after installing that you can just check it by typing BWA. Done?
Yes, ma'am.
Yes, ma'am.
Yeah. So you can see like the manual is opened here, right? So now we have to align the reads on the reference genome, right? So we need to check it again, the data. So this data has been taken for like from human, right? So in real time, we have to download the entire genome of the human, correct? But right now, we are only interested with the TP53 variant, and also the configuration in your system, it is not going to support this heavy file. Okay. So we want to execute this pipeline very smoothly. So what I suggest you, this TP53, if you see from the NCBI, So if you scroll down, this TP53, it is present on chromosome 17. Okay. So we are going to take here the chromosome 17 as a reference genome. Okay. But in real time, whenever you are doing any project, just make sure if your sample is your like human, so you have to download the entire genome of human. Okay. Got this?
Yes, ma'am.
Now, how to
Yes, ma'am.
download this? Just go to the UCSC. And there is an option downloads genome data, and you can see there are a lot of
Ma'am, could you
other.
please wait for a minute? Uh,
Yeah, yeah.
my internet connection is a bit slow, ma'am. Just
No
give me a
problem,
minute.
no problem.
Yes, ma'am. Now, what should we do?
Okay, so now there are a lot of like other organism also, but we are interested with the human, so we are going to select here human. Now you can see there are a lot of assembly for your human. Can you see? 2003, then 9, then 13 and 22. This is the latest one, right? So which assembly we have to choose? Any idea?
13, ma'am.
Why 13? Any
Because
time.
20 is latest and
Okay. See, you can see here in this bracket T to T. So it is not containing the entire genome of the human, ma'am. It is only having the telomere to telomere information. But we are interested with the entire genome, right? So that time you have to always go with this assembly that is present GRCH, and always go with the latest one. Okay. So this is the latest one, right? Of GRCH. Did you got this? Now, if you want to like download what? Which chromosome here? 17, right? So you have to go here, sequence data by chromosome, scroll down, and you will get a lot of link here. Just go to the chromosome 17. Can you see chromosome 17.fa.gz? So this is the FASTA sequence of the chromosome 17 here. And what you do, just right click
Ma'am,
it from
I'm
here. Uh-huh. Yes,
Ma'am, I'm
Moira?
so sorry to interrupt. I think I'm a bit lost here with the whole UCSC browser. Could you please help me to
Yeah,
navigate
yeah,
to
yeah,
this
yeah, yeah.
page? Can
Yes,
I
yes,
share
yes.
my screen?
Mm-hmm.
Can you see my screen now?
Uh, Not yet.
How about now, ma'am?
Yeah. Just go to the downloads. In the download, there is a genome data,
Okay, ma'am.
and select that.
Yes, ma'am. I'm sorry, ma'am. The internet is a bit slow
No problem, no
today.
problem. Now select the human from here. Now you can see there is December 2013. Yeah, sequence data by chromosome. scroll below, like down, scroll down, and you will get the chromosome
This one,
7.
right?
Yeah, chromosome 17.fa.gz here. Okay. Now, what you guys have to do, um,
Where should I download, ma'am? In the DNA seed folder?
just wait. I will tell you. Wait. Can you see my screen?
Okay. I'll stop sharing the screen now.
Yeah. What you guys do? Uh, just right click it, copy the link address, and go to the script. Below, just type here download chromosome 17 from UCSC browser and type the command wget-c and paste that link.
Yes, ma'am.
Now, copy this link and run it in your folder. So it is going to download your chromosome 17. Now you can see here, do it ls. You can see the chromosome 17.fa.gz. It is in the compressed format. Can you see?
Ma'am, it is still
So,
downloading for me, ma'am.
okay, no problem. Once it is downloaded, just let me know.
It's done, ma'am, for me.
Okay. Done, ma'am.
Now you can see it is in the compressed format. We need to uncompress it by Linux command, that is gunzip, and copy this file. Now
Done, ma'am.
you can see here chromosome 17.fa is your now reference genome. It has been extracted. Now what you do, just simply paste this command. Done.
Yes, ma'am.
Okay. So in this, there is first step is that indexing of your reference genome. So can you tell me what is the indexing? Why we are indexing the reference genome? Why we are not directly mapping the reads on the reference genome? Can you tell me? Any guess?
What does induction means, ma'am?
Okay. So right now we are having a chromosome 17, right? But in real time, you are going to download the entire genome of the human, correct? So as a, like, if you are having the genome of the human, that means it is going to take lot of time, right, in the mapping. Almost, it sometime it is taking the 5 days also for the alignment if you do not do the indexing. So with the help of the indexing, what it do, it is going to reduce the alignment time. This is the first reason. And second reason is that the chromosome 17, it is going to convert into the binary files. Why? Because in the pipeline further we want to run the different tools, right? So the tools, it is not going to take your FASTA sequence. Why? Because that is the FASTA sequence, it is not the computer readable file, right? So chromosome 17 we can read because this is in the FASTA sequence ATGC format. We can read as a human, but tool cannot read that. So this indexing, what it will do, it is going to convert the chromosome 17 into the binary files. Okay, and in that binary files we are going to align our reads. Did you got this?
I'm really sorry. Could you please repeat? I couldn't understand, ma'am.
Okay. So Moira, see here, where it is. Yeah. Right now, we have just downloaded only chromosome 17, right? We can directly map our reads here on the chromosome 17, right? But further, the tool cannot read this FASTA sequence. Why? Because the tool need the binary files. Okay, this is not a computer readable file. This is only just a human readable file. If I try to open this chromosome 17, you will get a FASTA sequence, right? That we can read as a human, but the tools cannot read. Okay, and in real time you are going to download what, the entire genome of the human from here. This is your genome of human, this one sg38.fa.gz. Okay, so in real time this genome is the huge, right? If you try to align your reads here on your genome, it is going to take a lot of time for mapping, right? But as a bioinformatics, we want to reduce the time also, correct? So that is why we are doing the indexing here. Did you got this now?
Yes, ma'am. Just confirming, indexing is like turning a file into a binary form.
Right,
Is it right,
right,
ma'am?
right. This is the first
Okay.
reason. Like, it is going to turn the FASTA sequence into the binary file. And second reason is that it is going to reduce the alignment time. This is the two reason. Okay.
Okay, ma'am.
Now I will type here BWA. So I'm going to index my genome, right? So you can see this, there is a option index here. So I will type here BWA index. Now how to use this BWA index? You can see here, first call the BWA index. And there are some other option also that you can also provide in your commands. So you can see there are two algorithm in the BWA. You can see here DWTSW and DIV. So if if your genome is large, for example, you have taken the genome of eukaryotes, that time you are going to use this algorithm. But if your genome size is short, or if you have like taken the genome of bacteria, that time you can go with this algorithm DIV, or maybe if you are taking any virus genome. Okay, so like right now we are taking what for the human. So can you tell me which algorithm we are going to use here?
The first one, ma'am. BWTSW.
Yes. So I will make the command bwa index hyphen a, and then this is the algorithm we are going to use, and then you can give your file name, that is chromosome 17.fa. This is your command. I will paste here, and you can also do that.
Ma'am, do we have to run this?
Yeah. Now after this you can run.
Done, ma'am.
Done this step. Okay. Now if you do ls here, and if you go inside your folder, you will get this file. Can you see this one? Can you see this? So these are your
Yes,
binary
ma'am.
files. That bwa has been created. And further, in the next step, we are going to align our reads on this binary files. Did you got this now? Any doubt
Yes,
till here?
ma'am.
So you can
Ma'am,
save this.
No,
Yeah,
ma'am.
yeah, yeah. Yeah.
how many files are we supposed to have, ma'am? This chromosome 17?
Yes, ma'am. What?
Like, how many files are we supposed to have, ma'am? Five or something like that?
No. See, one. This is total five, I guess. Yeah, this file.
Okay, okay, ma'am.
Okay. Yeah. So
What are these files, ma'am? What,
these
each
are
file
binary
consists of
files,
what,
na?
ma'am?
These are only the binary language, okay? 0 1 1 like that. But we cannot read that as a human, okay? That tool can read, okay? It is just converting the FASTA sequence into the binary format. That's it.
Okay.
Okay, so there is like why we have taken this BWA tool, so that you have to answer me like maybe on Monday session, okay? Because tomorrow and like then after that there will be Sunday, there will be 2 days off for you guys, so just let me know this answer on Monday, okay? And then we can end here.
Ma'am, the question is why